All right, so I just tried doing a video with this and I failed a few times. Last time I failed because I put candy in my mouth, didn't realize that that would make it harder to talk. But anyway, we're doing a Nix Advent of Code. This is following up on the previous one where we did 2019 day 2, but I didn't realize there was a part 2 to day 2, so we're doing that today. I tried doing this once and then I really fumbled on the explanation for my solution on like something. You'll see when we get to it. So I'm just gonna do it again. You know, we love coding Nix anyway, so this is good. You can pause and read if you're following along. The main thing, like the summary basically, is that we got a solution at the end of running our code, right? Here, not Nix REPL, here we go. We ended up with a solution here. The solution's always in the first position. It's basically like a little computer where it reads like opcodes and arguments and has a program counter, instruction pointer, stuff like that. But now, instead of like just solving for it, they want us to basically change these first two parameters, the 12 and the 2, to find out which combination of these two parameters is actually going to give us a result of this number 196,90720 in this first position. Luckily, it's bounded, so the x and y, or the two numbers, are basically constrained to be between 0 and 99. So you don't have to worry about it like being like some infinite possible set. I think that's it for us to just get started. So I was sort of tempted to clean this up a little bit last time. Let me just like these lines, like we don't really, no one's ever going to care about these lines, right? So let's get rid of them from the top level and just keep puzzle input. And we'll still do these calculations in a let. Right, something like this. And then we return the puzzle input. So we don't need to call this puzzle input anymore. We just map it. I really like putting it over here. Anyway, that should work still. Puzzle input's the same name, so the program should continue to work. Yep, it does. And how are we going to approach this thing? Well, one thing I kind of want to do is first come up with all the combinations of solutions. Like if you call the first position x and the second position y, then I want all the combinations of 0 through 99 for x and 0 through 99 for y. We have 200. We have 100 for each, so the number of possible solutions should be 100 times 100. And that would be 10,000. So that's kind of where we're at. So let's write a function that will basically give us all the possible solutions. And we want it to look a little bit like a list of sets where we have like attribute sets where we have like x is equal to 0 and y is equal to 0. And that continues until x is equal to 99, y is equal to 99, right? I always forget semicolons in this stuff. So that's kind of like the way it's going to look, and there'll be 10,000 of those. So just to break this down, what I like to do is make it simpler. So if instead of making this right away, let's just make 100. Let's make y equals 0 through 99. Start out with that. And we have a function called range to do that. Lib range. So we'll just do let's do lib range. Lib range 0 through 99. And we'll get rid of this for now. and we'll call possible solutions. And I probably did not put a semicolon in there, like I never do. All right, so you can see here that we have a list. Let's get it closer into the format that we want, where each of those items, let's actually, let's make something called like max vector length. And let's just make it 3 for now. Oops. That way, when we print stuff, it won't be too complicated to look at. So, yeah, 0, 1, 2, 3. Actually, let's make it 2. It's even easier. Perfect. All right, so now we want to convert each of those numbers into an attribute set, right? So that is the first thing you think is if you're going to iterate through a list, map is probably a very good go-to function. So let us call map. And we will map, so here's some function, right? And here is the list. So the identity function should be like trivial. This is taking in an element, returning an element, so, still works. But instead of taking the element, we want to turn it into an attribute set. So we're going to make an attribute set. And we can do y is equal to e. Right? So whatever element that we're getting from this range, we're going to basically put it under y equals e. So now you can see that we have an attribute set, but we don't have an x, right? So if you're super lazy, you can hardcode an x. And now we have a possible solution set. Actually, we want to be so lazy that let us now try to code a testing function. So the test function is basically like, hey, is this solution possible, right? So test solution. It's a function that takes in, we're going to need a few things. We're going to need to know the x, the y. We'll probably need the whole puzzle. And the target, which is like the solve, right? Like what we want. Expected. All right, I think that's all we need to test the solution. So what do? We test the solution by, actually, I want to put the puzzle first because it's sort of like, I don't know, in my head it's like the biggest thing. So let's pass it in first. So we can, first we have to put in x and y into the puzzle. And I think you can see replace is up here on line 55. So we're gonna replace the puzzle. And so we'll do replace. It takes in the puzzle, which is puzzle. It takes in the position, which is 1, because x goes into 1. And yeah, that's it. So now this is going to return us the new puzzle. So we'll just call it like puzzle 1. All right. We'll need a let in here because we're going to have to do this a few times. So this is puzzle 1. We're putting in the x. And then puzzle 2 is replacing puzzle 1. Make sure you use the updated puzzle. We're putting it in position 2, y, right? And what's next? Now we can actually process this, right? And process was right below us. So let me just type it in first. Process, and we pass in the puzzle, which is puzzle 2 now, right? And where to start from. And it's always going to be 0 for the very first one. And this will return us a new puzzle that has the very first element is going to be the solution. So we can call that the head, and I think it's called, there's built-in's head. Built-in's head gives us the first element of a list. So here we're getting the first element of whatever, basically getting the solution. And now we have enough to answer the question, is it a solution? We say, is head equal to expected? Semicolon, because we're assigning it to this name here, this variable. All right, so now we can test a solution. So we have possible solutions and we can test a solution. So it seems like let's just test whether test solution compiles and runs. So test solution, we give it like needs a puzzle, and I think that calls it input puzzle is what we called it. It needs an x. We'll give an x of 1, a y of 1, and the expected answer that we want is this. So what is that? Expected. All right. Process, I spelled it wrong. It did look funny on the screen. Puzzle. Undefined input puzzle. What is it called? Puzzle input, of course. Puzzle input. All right, so it compiles. It's kind of a funny thing. We could test this by like figuring out what the result was and then testing for the result, but let's not do that. Let's just assume that we coded something that worked and continue, right? So if we have, we can test something and we have the possible solutions, maybe we got lucky and it's one of these where x is actually equal to 0. Wouldn't that be funny, right? So we're kind of writing this backwards. So now that we have all the possible solutions and we want to test each one, what does that make you think? That makes you think like, well, you know, like I said earlier, map is a good go-to if you got to go through a list, right? And we have a list of possible solutions. So why don't we try map and see what happens? So we do map, and it needs to take in a function. So it should take in test solution, right? And what is the list it's going to use is possible solutions. So it gets passed in the possible solutions. So we have like an x here. Maybe I'll do it like this. It has an x and a y. No, this is not. It is an attribute set that we're passing in, and then we call test solution, and we use x is equal to x, and y is equal to y, and expected is equal to that thing. So that's the function that we're mapping each possible solution into, right? So possible solutions, remember, it's a list of attribute sets that have x and y in it. And so we make a function that takes that in, and then we're calling test solution. And the puzzle input's always going to be the same initial puzzle input. That's what's great about these immutable languages. We don't have to worry once we've set that. X is x, y is y, that we get passed in. Yeah, this looks right. Do I need any semicolons? I don't think so. So let us try this. So as you can see here, map gave us false, false, false. But what we really want is um, just like to cull the list, like filter the list of possible solutions to only the solutions that actually match. Um, so let us then do that. So there's a function called filter that takes in a function, and that function is basically going to iterate through the list. Well, filter is going to iterate through the list, and each element is going to be passed into the function. If the function returns true, it keeps the element, and if it's false, we get rid of it. So it should kind of go pretty well in here, built-ins.filter. Our function is taking in this x and y, and it returns true if we want to keep it, and it returns false if we don't want to keep it. So I think we don't actually have to do anything else. And as you can see, there is no solution. So why don't we do something a little crazy and actually like try to find out what does a test solution give us. So let's just trace it here, and we'll print out something here. Trace takes in the first argument that's going to put to standard error or output, I don't know, and then it returns the second. So basically, whatever we were doing anyway, we keep it in the second argument. And here we're going to basically say what was our solution. So we'll have like x is equal to x, y is equal to y, and head is equal to head. You can see that here. These are numbers, so we have to call toString x. ToString. Why do I keep doing that? I'll never be an OSU player. And toString head, right? So I think, oh, and trace is a built-in. So let's see how that goes. Okay. Oh! X, Y. Why is it always passing the same X and Y? Oh, hold on. Because I had a typo. If this was a live stream, you know, maybe these would go better because you guys would be yelling at me that I had a typo. All right, so you can see the numbers are changing. So if the solution we wanted was, here, let's change this for a second. If the solution was expected is equal to 337062, then one of these would actually stick. That would be the y is 1. Let us see if this works. Yes, you see, so it kept that 1 and the others are gone. So in a way, we know that like our function sort of works. Yeah, so here we'll just get rid of this. Oops. We'll just join here, and we'll just put this back. All right. So now none of them will work again. So what we have to do now is figure out how do we get x's to be added on. All right, so this is where I had a little bit of a hard time explaining, and I really fell apart last time. And I think I have a better way of explaining it. So instead of jumping to the solution, I want to bring up Nick's REPL. So what we have is basically a function like, right now what we have is like use x, make y's, right? Where it's a function where we take in an x, and we will make y. So let's do this. It's some function that takes in an x, and we'll write the rest of it. And then here's the input, right? So if it just did this, oops, I keep forgetting what language I'm using. If this was the function and we use x make y's and we passed in like a 1, use x make y's. No, it needs to be a function, and I didn't call map. It needs to be a function. You see why I'm falling apart again. And we call map. It takes in an element, and it returns the element, let's say, right? So here we go. This map is just returning the element we're passing in, and then use x make y's 1. You see that it's basically, it doesn't matter what I pass in because there's no x yet, right? So what I'm trying to get back to is that function we had before, where we return x is equal to x, y is equal to e. All right, so now we call this here. We have to use print to get into strict evaluation, so it's not lazy. And now you can see basically why I called it use x make y's, because this thing is it's going to take in an x, which is 3 here, and it's going to make y's, right? So here we go. It took in an x here, and then we call map, which basically iterates through this list 0, 1, 2, and it turns each element into an attribute set that has x and y, just like this, right? So now what we want to do is like pass in a new like different x's, right? So now we do like map, and we're going to pass, let's think about what we want to pass at the end. It'll be the same thing, 0, 1, 2, 0, 1, 2, right? And we want to change each of these elements, so it's always going to be like an element, and then we're going to use x make y's with it, and we're going to call e on it. So what this should do is turn this element into this list. All right, so just remember that when we did use x make y's, it returns a list, right? It returns a list that is the possible sets of y's with a set x, a given x, a constant x. Now, when we do the second level mapping on it, because remember there's a map in here, right? It's basically mapping this 0 into a list of these y's. And since it's already a list, each one of this 0 now is going to be a list, right? So you can see like this 0 is going to turn into some kind of list. We don't, whatever list, oops, I lost it. You get what I'm saying, right? Each one of these is going to turn into a list because this thing returns a list. So we're going to end up with a list of lists if we keep doing it this way. And that is a little bit of a complicated thing, but you can see, like, just like I said before, like whenever you have to iterate, why not think maps? So maybe we'll do that. This is a little dangerous. So let's move this up, right? So map takes in a function, whatever that function is, and it's going to take solution set. Where do we pass the last solution set? Possible solutions. Oh, max vec length. Right. Okay. So we'll just make another range then, right? lib.range 0 to max vector length. And we don't need this because this is going to return, but we do need this thing to be in parentheses because map expects two things. You know, if you don't have the parentheses, it's going to just be confused and think lib range is the third parameter, and that's not what it is. All right. So possible solutions is, let's move this up 1, 2, and let's get rid of that. So we're basically saying map, and now what's the function? Well, it's going to take in one of these things. We'll call this one I, right? And then Why did this thing have a semicolon? Because that was the end of the function. All right, so now we're going to pass in an I that is this thing, and we're going to call map with it. But now we're going to x is going to become I here. So this thing is going to be called into, each one of these is going to go into this function, and this function turns it into a list, remember? But now it's going to be a list where x, it's going to have all the different x's. So let's try running that. Didn't like that test solution because we need a semicolon here now. X and Y needs to be a list, right? Because this is a little bit, this is not what we want to test for anymore. Let's just show possible solutions. Okay, so let's take a look at what we got. Here we go. So we have a list, and then we have another list that is all of these, and then we have another list which is all the x's are equal to 1. Then we have another list, and we have this, right? Because remember, the 0 turned into this, the 1 turned into this, and the 2 turned into this, right? And that was through that function. So hopefully that makes sense. But we don't want a list within a list. We just want a list of possible solutions, right? So in a sense, we want to get rid of all of these brackets. And a good way to do that is to use fold instead of map, because fold is another language sometimes called reduce. It's basically a way to build something up rather than mapping something. So we're going to go ahead and use fold instead. Let's bring up fold here. I don't know what the different folds are in here, why there's a fold prime, but this is the way it works. It gets in a function, null and a list. Null is basically what you start building it with, and for us, here we already know that if we're going to do this as fold, and this is in, where is this, lib? Built-ins. That it takes in a function. Here's a function. We need to add a null, and the null for us is the empty list, because remember, we're adding this into a list. Each one of these things that the build y basically was returning is going to go into this list, and we still keep the same list to start with. So that seems right to me. All right, so now what's the function? The function is different. It takes in two values. The the accumulator, which is, I call it the accumulator, which is the null, right? So we call it the accumulator, and the element from the list. So what do we want to do with the accumulator? We want to take this map we're generating and we want to concatenate it with the accumulator. This map is going to be smaller, so I guess I would add it to the accumulator in the end like this. Let's see where we need parentheses. Map. We probably need parentheses around this map because it's one whole function, and then we want to apply the concatenation operator to it and add the accumulator to it. I think that's right. So let's see here. No. This is not how a function takes in two parameters in Nix. All right, great. So let us see how this one compares to the other one. Oops. So here we have a list. Inside the list is this one, oops, this one. We see no list within lists here, right? So that's a good sign. And here's all the zeros. So yeah, this one looks correct. We'll just kind of eyeball the... We have 2's here, and you have all the various y's. We have the 1's, and we have the 0's. So I would say that this is what we want. And now we should be able to possible solutions. So now our possible solutions are basically up to 3. And we can try running this now. And you can see that there are no solutions at the end. So we are not lucky there. Let us now get rid of this trace. Or should we keep the trace? We'll keep the trace. And now we'll just change max vector length to 99. And if we're lucky, we will actually get a solution here in the end. Otherwise, we're going to go into debugging, and that'll be fun. So you can see all the various permutations, and it found a solution. There is one solution where x is 42 and y is 59. So if we go back to here, we have to answer what is noun plus verb. Noun is basically our x and verb is our y. So let us find out what that answer is. And of course we use Nix REPL. 100 times, well, let's do what they have first as an example to make sure we are doing this right. Times 12 plus 2. And that gives us 1202. So now we put in our numbers. 100 times 42, that was our x, plus 59 was our y. And the answer is 4259. Yeah, well, it is the right answer because I already did this once and it showed the right answer was this, I think. You don't seem to be... Did you already complete it? I wonder why it's saying that. Here, maybe I just need to reload it. You should return, get your puzzle input. If you still want to see, you can get your puzzle input. Oh, the puzzle answer was 4259, and you see 4259 here. So perfect. So this time around, I hope this made more sense. You won't ever know because you won't see the other video I did. But that's okay. I will commit this into GitHub. So that is in the description. You can find that there. Um, and I guess that's it. If you found this interesting, please do like and subscribe. And we'll be doing more Nix in general. I'm still going through the Nix stuff. Like I think we were just packaging stuff in the last session here. Packaging existing software, and I think we're here somewhere. So we're getting through it. People have been talking about flakes a lot to me, so I wonder where that is. But anyway, we'll get there. Thanks so much, and see you soon.